Now that we have the background information for linked lists and how they work, we can talk about how the Java collections linked list looks. So we wrote our own linked list class, but this has already been done for us and included in Java's util library. So that includes more than linked lists. There's array list, tree set, hash set, there's a whole big collection of them. And depending on your circumstances, you may need to use a different one, but we won't discuss which suits which job for now. So generally you will use something from the Java collections rather than building your own. And there are a few good reasons for this. It's built consistently. There are certain features that you can use across different collections and you don't have to remember how your particular collection works. So for a linked list and an array list with the Java collections, you can do a for each loop and it's already implemented. It's also used in most third-party libraries. So if you were to download a third-party library from the internet, it would already be compatible with the Java collections. You wouldn't have to write your own classes and cater them towards the new library specifically. And they're also rich in features. They've all got everything you need implemented. So it's only the exceptional cases when you would need to write your own. So here's a small example of using the linked list. Now this looks strikingly similar to how it was when we used our own linked list. We can see at the top that we have had to import linked list. But once we've done that, we can just use the linked list as you see on the screen. So creating it is the same as always. We just have to give it the type that we want to initialize with. So string in this case, and then we can add things. We can see at the top that we have had to import linked list. But once we've done that, we can just use the linked list as you see on the screen. So creating it is the same as always. We just have to give it the type that we want to initialize with. So string in this case, and then we can add things. Here's another example where instead of using a string, we're using an integer. And remember, we have to do this with capital I, full word integer, because it's the class, not the native type. And we can do the same thing, add 3, add 4, add 5, not a problem. Here's another example where instead of using a string, we're using an integer. And remember, we have to do this with capital I, full word integer, because it's the class, not the native type. And we can do the same thing, add 3, add 4, add 5, not a problem. There are a whole bunch of methods. I'm not going to go through them all because it'll just be a waste of time. We can see that the add method we just used then appends the specified element to the end of this list. So this is when we add it and we don't want to keep any particular order. We can add it at a certain index if we like. There are lots of different methods there, so have a read through this. If you go to this URL or just search for Java collections, you'll find a good reference like this. So what we've been doing so far is using linked lists to only hold one type. So we've used strings, we've used ints, at one point in the previous video we used person. But what happens if we want to use any sort of inheritance? I want to keep a big collection of all of my animals, where each of them is a member of a subclass. I've got cats, dogs, and I've got elephants. Easy. So with these linked lists, and with the ones that we wrote, you can put the base class as the type. And then into this class, you can put anything which derives from that. So long as they're not abstract classes, of course, but that's just a general rule. So we can always add a cat into our animal list because we know that cat is a subclass of animal. So that's okay. This one might not be surprising to you, but the same can be done with interfaces. So if we have objects which implement the same interface, we can create a linked list which holds objects of that interface. Let's have a quick look at an example of that. This is for some fake game which doesn't exist, of course, it's missing a lot of code. But let's pretend that we have our enemy class, okay? Now, everything that exists in our game extends the game object base class. So everything is in that tree, right? This is at the very top of the object hierarchy. And certain things may have physics and they may be drawable to the screen. So a tree, for example, is a game object also. It's drawable, but it doesn't have any physics. Perhaps this tree isn't really interactable in the game. It doesn't listen to the wind or anything. So all this one can do is be drawn. We have our tree constructor and we have a draw method, which we will assume comes from our iDrawable interface. With an enemy, they also have the iDrawable interface, which means they have a draw method, but on top of that they also have physics. They would likely have other interfaces, but this is just a simple example. So having implemented the iHasPhysics means that we now have our update method. That's where we do our physics calculations each game loop. So keep that in mind for a second. This is a basic running of our game. Not a very good game, but it's still what we need. So we've included the linked lists library, and we've created 2 linked lists. The first one, we can see that we call the method called loadPhysicsObjects. We can pretend that this one goes off to a file and loads in all the physics objects and returns a linked list of IHasPhysicsObjects. And we put it into this linked list here, physics objects. We do the same thing with all of our drawable objects. So this method here will load all of the models, all the sprites from a file. And from there it returns a linked list of iDrawable, which we call drawObjects. So at this point, we know that based on our previous view, where we saw that tree had drawable and enemy had IHasPhysics and iDrawable, we can assume that drawObjects has both enemy and tree in it. PhysicsObjects only has enemy in it. We don't know of any other classes which implement these interfaces. So in all games, we have our game loop. We'll just have a while loop that goes on this gameActive boolean. So the very first thing is we'll process the player input, whatever that means. After that, we can go through using this same for each loop. We can say for each IHasPhysicsObject P in PhysicsObjects, update. So because we know that all of these things in this list implement this interface, we can be assured that they will have this method, this update method. So we can call that. The same thing happens with our drawObjects. For every iDrawable object D in drawObjects, draw. So again, the only things in this list, they must implement that interface, so they must have this draw method. That's just one small example of how linked lists can be used with interfaces rather than with base classes or superclasses. Just on a side note, a slightly better version of this code would be, right now, because I've loaded the drawObjects and the PhysicsObjects separately, I know that enemy is in this one and in this one, which is a duplication of memory. Instead, I could just have a linked list of gameObject. So now, instead of having a linked list of interfaces, I have a linked list of a class, some superclass that they all must inherit from. So when I load my gameObjects, it will load all of the drawable things, all of the things that have physics, but overall it will load everything that is a subclass of gameObject and put it in this list. So we have a similar loop. While the game is active, get the player's input, of course, and now for every gameObject G in our gameObjects, if that particular one we're looking at, if G is an instance of IHasPhysics, then we can call the update method, because we know that all objects that implement the IHasPhysics interface must implement this update method. So we'll have to cast them to IHasPhysics first, of course, and then update. And the same goes for our gameObjects again. If the one we are currently looking at, G, is an instance of iDrawable, or it implements that interface, we can cast to iDrawable and call draw, because as we saw before, iDrawable means you must have this draw method. So that's just a quick example of how you would use linked list. Again, I won't tell you about all of the methods that are available because the API does tell you all of that information. So I won't go into details of any more collections because it's outside of the scope of this lesson. But if you look up Java collections, you'll find all the information you need. As long as you know how to construct the object, and you can find that by searching for the constructor in the API, and as long as you know which methods are available and what they do, which you can also find in the API, you're pretty much done.